All right, no wonder I had a little bit of issue on the last portion of the video is because I wrote secant equals 1 over sine. I hope all of you are thinking Miss St. John is an idiot. Secant x equals 1 over cosine x. That makes so much more sense that y secant equals 1 at 2 pi, because at 2 pi cosine is 1, so you get 1 over 1, which is 1. I was trying to make this sign work and it wasn't. I totally apologize. How many of you caught it? Come see me if you caught it. I'll give you like a little treat. You have to prove to me that you had it wrong, that I had it wrong. All right, 2 more examples in this section. Graph secant of pi thirds. So secant of pi thirds is, how the function is meant to be written is secant of k theta, where k is some value. Well, in this case, see how this can be written as secant 1/3 theta. So we know that our k equals 1/3. And remember, when we did our graphs, we learned that the period of each of the trig functions was either pi or 2 pi. Well, cotangent and tangent are pi, so therefore the period in a secant is 2 pi, and we need to divide that by k to see how what the period of this equation is, because it's normally the period is 2 pi, but we're multiplying in a factor here of 1/3. So we're going to take 2 pi divided by 1/3, which is the same as 3 times 2 pi, or 6 pi. And so we know that our new period is 6 pi. So let's go ahead and graph this. And the easiest thing to do is secant is go off of our cosine function. Well, our cosine is the cup, so we're going to go here. It's just going to get stretched out so that this is 6 pi, right? And it's going to come this way and just get stretched out. So that means when we go to graph secant, we're going to go off of these. We can put in our asymptotes. Okay, our asymptotes are going to be where cosine is 0. This pen doesn't work anymore. So our cosine is 0, 0, 0. So when we go to graph it, get this, we get this, and we get this down here too. That's how we get our cosecant. This is my 0 right here. And this is half, it would be halfway, so this would be 3 pi. Okay, so it's just been stretched out once you find the period. That's why it's important to remember that the period is 2 pi. All right, oh, and I just did all of that where you couldn't see it. Well, that was so nice of me. All right, so here's my cosine stretched out to 6 pi. Wherever the cosine is 0 is my asymptote. So these are my asymptotes wherever cosine is 0. And then secant is all the parts in between. Okay, this is very, very ugly, but you get it, and it's not drawn to scale. All right? Last example here. Write an equation of the function with the given information. So we want a tangent function. We're told the period is 2 pi, the phase shift is 0, and the vertical shift is -6. So how that works is we're going to let k is going to represent we're going to set that equal to our period. That's our period. I'm going to have a number c that I call that it's going to reference the phase shift. And h is going to be my vertical shift. And how we write that equation is going to be y equals tangent of k theta plus c plus h. Okay, that's just the standard form. This is like our secant, our little factor that we multiplied the period by. C is our phase shift, and then H is our vertical shift. So again, remember our period for a tangent is pi. So, but we're told that our period was 2 pi here. So we're going to take 2 pi and set that equal to pi, which is our regular, a normal period for tangent, and figure out what k is. So I could do cross products, or let's see, what do we just, I'll do this. I'm going to do pi equals, doing cross products, pi equals 2k pi. And then I'm going to divide both sides by 2 pi. And we get k equals 1/2. Okay, that is my period every 1/2. So this is going to go 1/2 in here. How do we find our phase shift? Well, for the phase shift, what are we told? That it's 0, so we don't have to do anything. We're just put a 0 in for C. And then our vertical shift is -6. So our final answer for this one is y equals tangent 1/2 theta. Remember, the phase shift is 0, so I don't have to put any number in. And I'm going to shift it -6. Okay. I'll do one more. Hopefully you guys saw that. I didn't look at the camera. What if I give you secant has a period of pi, phase of -pi force, and a vertical shift of -10. So again, we're going to, our secant, that pi is equal to 2 pi. So we're going to say 2 pi equals, we're going to say pi, because the last one was 2 pi. We're going to take this pi and we're going to set it equal to what normally is, divided by k. We're going to solve for k. We get 2 pi equals pi k. Divide both sides by pi. You get k equals 2. That's the first thing I need. My phase shift, we're going to take C over k equals -pi force. This is what you need to do. You need to take the C, plug in the 2 that we just found for k, and solve for C. So I'm going to do cross products. -2 pi equals 4c. Divide both sides by 4. I'm trying to fit this all on my page. So I get -1/2 pi equals c. And then the last thing is the vertical shift is 10. So my equation is y equals secant of k was 2 theta minus 1/2 pi my c minus 10. Sorry, my paper is ugly. Please come see me if you have questions. I'm in room 410. All right, that's it for this lesson. This was a big one. The next one's shorter, I promise.